Hello students, welcome to our channel Math with Gigi. Today's topic for the video is how to find YP using general method. Before the start of video, if you have not subscribed our channel, please subscribe our channel so that you will get the notification of the latest video. So let's start with the today's topic. General method to find YP. Before we actually start with the general method, let us discuss when this method is applicable. This method is useful whenever shortcut methods are not applicable. Now, what are different shortcut methods? There are 6 types of shortcut methods that are depend on the value of f of x. If the value of f of x is neither from those 6 shortcut types, then we have to use general method to find YP. I'll again repeat. If the shortcut method is not applicable, then and then only use general method to find YP. So let's start with the general method. Step number 1. The formula for YP for general method is 1 upon phi of d f of x. This is similar to shortcut method also. YP equal to 1 upon phi of d f of x. Then in step 2, find the factors of phi of d and use partial fraction to express 1 upon phi of d in the summation or subtraction of the terms like 1 upon d plus a, 1 upon d minus a in the linear factors. Step number 2 is find the factors of phi of d and express 1 upon phi of d as addition or subtraction of linear factors in the form 1 upon d plus a, 1 upon d minus a using partial fraction. If you don't know partial fraction, you can watch our partial fraction video. The link is in the description below. The next step, here we will use the formula for general method. The formula is 1 upon d plus a f of x is equal to e raised to minus ax integration e raised to x f of x dx, and 1 upon d minus a f of x equal to e raised to x integration e raised to minus ax f of x dx. So in step number 2 we have done partial fraction and we have expressed 1 upon phi of d as addition or subtraction of the terms like this, and then we separate f of x to both the terms. Use the suitable formula given in step number 3. Integrate the terms, simplify, and the expression you get is the required solution or required YP for the given example. So we will take the examples of this method. In this example, we will not cover how to find YC. We are just covering how to find YP using general method. For YC, we will upload a different video for it. So let's discuss a couple of examples based on how to find YP using general method. Now, if we start with the step 1, the formula for YP is 1 upon phi of d f of x. If you observe, the value of phi of d is d square plus 3d plus 2 and f of x is e raised to x. Now, if you observe the value of f of x, it is neither of the shortcut method number 1 to 6, any type. So, we have to use general method to solve this YP. So, in next step, we will factorize the denominator. So, if you observe 1 upon d square plus 3d plus 2, the factors are d plus 1 and d plus 2. So, this 1 upon d square plus 3d plus 2 can be expressed as 1 upon d plus 1 into 1 upon d plus 2 e raised to x. Now, we have to use partial fraction to separate this into addition or subtraction term. Let us call this as equation number 1. Consider 1 upon d plus 1 d plus 2 is equal to a upon d plus 1 plus b upon d plus 2. Cross multiplying and cancelling the denominator, we get a into d plus 2 plus b into d plus 1 equal to 1. Now we have to put d so that one of the term gets 0. Put d equal to minus 1. We get a into 1 plus b into 0 equal to 1. Therefore, a is equal to 1. Put d equal to minus 2. So, a into 0 plus b into minus 1 equal to 1. Therefore, b equal to minus 1. Hence, 1 upon d plus 1 into d plus 2 is equal to 1 upon d plus 1 minus 1 upon d plus 2. Let us substitute this value in equation number 1. Therefore, yp is equal to 1 upon d plus 1 minus 1 upon d plus 2 into e raised to x. If you are not aware of partial fraction well, we have a separate detailed video on partial fraction on our channel. The link is given in the description so that you can watch the partial fraction video and come back to this step. So we get yp equal to 1 upon d plus 1 minus 1 upon d plus 2 e raised to x. Now we have to multiply by e raised to x to both the term. So 1 upon d plus 1 e raised to x minus 1 upon d plus 2 e raised to x. Now we will use the formula for general method of 1 upon d plus a f of x, 1 upon d plus a f of x for both the terms. So we get e raised to minus x integration as d plus 1, therefore e raised to minus x, e raised to x, e raised to x dx minus e raised to minus 2x integration e raised to x, integration e raised to 2x e raised to x dx. Let us call this as equation number 2. So what we have done here, we have done yp using the formula of 1 upon phi of df of x. Then we have factorized the denominator. Using partial fraction, we have separated the denominator in this form. Then multiply by e raised to x and applying the formula of general method to get the equation number 2. Now we have to solve this integration separately by considering I1 and I2. Then we'll consider the first integration as I1, second integration as I2. We have to substitute and we have to solve. That's why we will call this as equation number 2 and separately calculating the equations will back substitute in equation number 2. Now let's evaluate the integrations of equation number 2 separately. Let's call the first integration as I1 and the second integration as I2. Integration e raised to x, e raised to x dx. I2 integration e raised to 2x, e raised to x dx. Now both the integration cannot be solved directly because of this term. So we have to substitute e raised to x as t in both cases. So for first, put e raised to x equal to t. Therefore, e raised to x dx is equal to dt. Therefore, I1 is converted into integration. Now this e raised to x dx is replaced by dt and e raised to x will be e raised to t. And integration of e raised to t is e raised to t. So this is equal to e raised to t. If we back substitute the value of t, we get I1 equal to e raised to x. Similarly, in this we have to use the same substitution. So put e raised to x equal to t. Therefore, e raised to x dx equal to dt. Now, this e raised to 2x can be splitted into two terms, e raised to x into e raised to x, and one e raised to x dx will be dt. One e raised to x will be remaining that we have to substitute by t. Therefore, I2 equal to this e raised to 2x is splitted into two parts. One e raised to dx is replaced by dt. One e raised to x remaining, that is t, and this term e raised to t. So here we will use the integration by parts or integration PF formula where P is polynomial. So as P is polynomial, we will use the formula. So T integration e raised to T minus derivative of T is 1, 2 times integration e raised to T dt. So integration of e raised to T is e raised to T minus double integration of e raised to T means finding the integration of e raised to T. So e raised to T integration is again e raised to T. Taking e raised to T common, we get T minus 1 in bracket. So back substituting the value of T, e raised to x into e raised to x minus 1. So these are the values of the integration I1 and I2. Now let's substitute this value in equation number 2. Therefore, yp is equal to e raised to minus x into first integration is e raised to x minus e raised to minus 2x. The second integration is e raised to x into e raised to x minus 1. Now we can take e raised to x common. So e raised to x in bracket e raised to minus x minus. We have to multiply by e raised to minus 2x to both the terms. So e raised to minus 2x into e raised to x will be e raised to minus x minus plus e raised to minus 2x. So e raised to minus x and e raised to minus x get cancelled. So we get e raised to minus 2x into e raised to x as yp. So this is the value of yp. So this is the example of how to find yp using general method. I hope this video is useful for you. Please like, share the video with your friends. And if you have not subscribed our channel, please subscribe and share our channel with your friends for such informative videos. Thank you.